All right, we're on the topic 4.3, areas of shaded regions. Let's review some area formulas before we start looking at some shaded regions. This one wants the area of this rectangle. The area of a rectangle is length times width. When you don't know the length, but it's written 30/90, you know this is a 60-degree angle. So that would mean this length right here is the short leg times the square root of 3. And that would now be our length. So we have 5 times the square root of 3 times 5. We're going to leave this in exact answers, so you will just leave the square root of 3 alone and multiply the two 5s. Always put that as a coefficient in front of your radical. So this would be 25 times the square root of 3, and it would be written as a square unit. So we'll put units squared. A square. The area is side squared. On this one, the side length, because this is a 45-45 90-degree triangle, that would mean that each side length is 12, because anytime you have a 45-45 90, the legs are always the same, and they're always the hypotenuse is times the square root of 2, whatever your leg length is. So if you divide that out, you'll get 12. So if we square our 12, that means our area is 144. This is just a review of some of the area formulas that you've learned. On this one, let's add the word equilateral triangle, or at least mark this, because this one was not marked, and so we do need to mark it. Let's mark it as an equilateral. I think I'm going to write that in parentheses right here. That should have been marked. When you draw this one, it's called an apothem. When you draw this right angle, you create a 30-60-90 triangle. If the radius is 8, then this apothem right here would be 4, because it's always, the short leg is always half the hypotenuse on a 30-60-90. This is 4 times the square root of 3, because it's the leg opposite the 60-degree angle. Now this is the one that we're going to use to actually get the perimeter of this, because on this, let me think, maybe we could, would that work? Well, I think I'll use the formula that's a regular polygon formula, 1/2 the apothem times the perimeter. If you remember from the previous units, the apothem is right here, this 4. So we have the apothem. Now the perimeter of this one would be taking this 4.3, doubling it, so that would make this length, any length that goes around, would be 8 times the square root of 3. And since you have 8 times the square root of 3 times, let me write that over here. Oops. Your perimeter is 8 times the square root of 3, but you have 3 equal sides, so that's going to give you 24 times the square root of 3. So that's what we're going to use for our perimeter. And then we're going to multiply by 1/2. 1/2 times 4 is 2. 2 times 24 is 48. So 48 times the square root of 3 is the perimeter. And since this one again doesn't have a unit, let's put unit squared. Alright, example 4. This one wants the area of a circle. Let's review that formula. Pi times radius squared. 10 is the radius. When you square 10, you get 100. So 100 pi would be your area. And again, this one doesn't have, oh, this one does have a unit. So we can write 100 pi square centimeters. So you can put the unit. You don't have to put units squared on this one. Okay, we're going to use some of these formulas for the next examples. Alright, this first part just wants you to describe how you would find the area of the shaded region below. On this one, because you're getting an area that's kind of an odd shape and we don't have a specific area formula for that, the first thing you do is you find the area of the square. We're going to name it A, B, C, D. And then you find the area of the circle. And then after that, if you know the area of the square, think of taking the whole area of the square and then pulling that out, taking the circle on the outside. So that means you're subtracting. So you subtract the area of the circle from the area of the square. Okay, let's find the area of the shaded region. So I'm gonna write it like this. The area that we want, the shaded region, is going to be the area of the square, subtract the area of the circle. So we're going to do side squared minus pi r squared. I'm going to go ahead and write my little, I'm going to make this is our formula. So when you take the side and square it, let's see, did they give us a side length? Yes. See, the side is 8, so it's going to be 8 squared, subtract pi times, now be careful, this 8 would represent a radius. I'm sorry, a diameter. So the radius here would be half of that, so that would be a 4. So we're going to take 4 and square it. So this would be 64 minus 16 pi. And this would be this answer would be in square units. So whatever this answer would be, this is called an exact answer. We're going to leave it in terms of pi. So this is our answer, 64 minus 16 pi. You could punch that in the calculator and get a decimal answer, but we're going to leave, for this section and most sections we do, we're going to leave it in exact answers. That's going to be a better way to write our answers. Alright, on this next one, they've given a shaded area on this outside of this triangle that's inscribed inside the circle. So to get the area of your shaded, you're going to take again, you're going to start with the circle, the outside shape, and subtract the area of the triangle. So that's how you're going to get your answer. So your formula is going to be pi times radius squared minus, and on this one, let me look, do we know the height and the base? Let's use a regular polygon again. It's 1/2 the apothem times the perimeter. So let's figure that out first. Remember that the apothem is this line that's a right angle. It's a bisector, perpendicular bisector of AC. This would be a 30, 60, 90. Half the hypotenuse gives us the apothem. Multiplying that, let me draw an arrow. Multiplying that times the square root of 3 gives me the length of the long leg. Now that would mean that 3 times the square root of 3 doubled, that each side length would be 6 times the square root of 3. And if it's an equilateral triangle, that makes it 18 times the square root of 3 for the perimeter. Our apothem was 3. Our radius is 6. So you're going to square 6. That's going to be 36 pi. 1/2 times 3 times 18 is 27. So we're going to leave it. This is kind of an interesting looking answer, but this is called the exact answer. Now if this were replaced in the calculator, it would give you a decimal answer, but let's leave it in exact form. Since we don't know the units, we'll put units squared. Okay, example number 7. This time we have a circle on the outside, and we're going to subtract the area of the trapezoid. So let's write our formulas. This is pi times radius squared, and we're going to subtract the formula for a trapezoid is a little longer. You have to add your bases, take half and multiply by the height. Let's see if we know all our units here. Let's see. Okay, it looks like we have another 30, 60, 90 triangle. From this point to, because it's an isosceles trapezoid, I'm going to go ahead and draw this line right here because I want you to notice this piece is 8. If the entire length is 12, that leaves this piece and the one over on the other side, these segments are both 2's, the total being 12. So if the 2 is the short leg of a 30, 60, 90, that means my height of this trapezoid is the short leg times the square root of 3. And that would be the h when I use this h out here. So I'll go ahead and write that. The bases of the trapezoid are the 12 and the 8. So that formula is not too hard. The radius of this one, if you look at the picture, 12 was this base, and it's also a diameter. So if the diameter is 12, the radius is half of that. So when we replace our formula for radius, we're going to have to square our 6. So this is 36 pi. When you work this entire formula right here, make sure you understand you're doing a trapezoid formula. It does have a radical in it, and we're going to leave it in radical form. So when you do the math here, you get 27. Oh, no, you don't. I'm sorry, 20. 20 times the square root of 3. And this is our answer because it's left as an exact. Radicals and pi are left alone to keep it an exact answer. And since it's area, it is a square unit.